And we need to be clear at this first part, but what we're dealing with in terms of the standard for high-speed token ring. Very key question about high-speed token ring and network management. Nobody wants to install a backbone network without knowing that it is going to be fully manageable. And as we look at how HSTR was developed and how the changes are minimal to the media access control, the silicon itself within Token Ring, it means that because you are running true Token Ring at 100 megabits, then you're inheriting all of the same management functions that we've known within the Token Ring area. We can take fully integrate existing silicon and build fully integrated products right from the start. And so we can be very cost effective with HSTR. In fact, our initial targets are to say, well, a high-speed port should not be more than 25% above a traditional server-type adapter. So we're looking at this application in the adapter sense of it being for the server initially, and therefore we're saying the pricing is very affordable, very integrated for the server application.
After Jeff had explained the product in full, Simon looked to the future.
What I'd like to do now is actually talk about one example, video conferencing, and how that's likely to be rolled out across an existing network infrastructure. And I'd like to use that as an example about why Token Ring is so powerful and how it will actually scale up to future application needs. What's the story for Ethernet? Well, unfortunately, for Ethernet users, the story is not so good. As I said before, this priority scheme, the ability to define the priority for packets on Token Ring networks, was actually defined from day one within Token Ring. Ethernet was never defined to support priority and was never defined to deliver any sort of quality of service across the network. Now, a lot of the Ethernet vendors have realized this is a weakness with Ethernet, and over the last year or two there's been a lot of activity within the IEEE standards committees to try and remedy this problem. Okay, what I'd like to do now is invite Jeff back up, and we'll then go through the demonstration here.
On this screen here, which we're going to show on the main screen, we have a video application running, and this PC is joined into the ring switch here using standard Token Ring. So we have standard Token Ring ports here, and underneath those ports here we have a new module, the HSTR module. It's a 4-port HSTR. But what we're doing at this stage is just having a look at a video here that is running local off the hard disk within the machine here. Now, what we're going to do is walk across here to the other switch. We're coming through HSTR here onto this Token Ring switch here, and the HSTR is a backbone connectivity between those two switches. And attached to this switch is the same configuration. We have Token Ring ports here, the 8-port module, coming into another PC connected to Token Ring. And as I bring that on, what we're seeing here is now the connectivity between those two networks. I can bring up a remote connection and therefore look at the server on the other network and bring network videos across those networks. So here we are seeing on this PC connectivity between the two switches in action. Now, moving on to here, what I'd like to have a look at on this screen is actually making a remote connection. Now what we're doing here with this other video is actually pulling across a video that is resident on this server. And that is running through the HSTR network, and to prove it, what I'll do here is remove the connection, and the video will carry on for a short time, stop, and then we'll plug in the connection again. Here we've broken the connection on HSTR, reconnected it, and shown you some of the resilience features of HSTR that would actually reconnect and seal the ring up and joining of these two networks.
Hi, I'm Mike Cohn. I'm the product manager for High-Speed Token Ring here at Madge. We're at Wexham Springs, Madge's worldwide headquarters for research and development, to have a look at how High-Speed Token Ring is measuring up to the 100 megabit per second claim. Let's go and have a look. Here we are in one of Madge's test labs. I'd like to introduce Gary Clark, our systems test manager. Gary, tell us what's going on here today.
Right, Mike.
Clearly, and where we were seeing the benefits here was the ease of which the switch can carry that packet right through the HSTR network. And that's partly down to the fact that we've got large packets support on HSTR. And we believe that, in fact, we're going to get a lot greater efficiency. Of course, those figures are still yet to come on the adaptive performance. We expect it to be very much more exciting in terms of performance compared with Ethernet.
Are there any questions from the floor?
In the 100 meg Ethernet world, it's quite common to find switches that will do 100 or 150 ports, full duplex. The port count on your plus switch there looks a bit lean in that environment, and as such, it doesn't seem awfully viable as a backbone concentration unit.
Okay, well, I think what you're seeing here is actually the first generation of high-speed token ring products. I do acknowledge that on Ethernet, fast Ethernet's been around for 5-6 years, and we're seeing that the applications for fast Ethernet are for aggregating. You've got switching within the work group. You have high-speed fast Ethernet uplinks into the backbone, so you might need a much higher density within the backbone. The first application, as Jeff was talking about in his presentation, for high-speed token ring is to connect switches together. So it's to build upon an existing switched infrastructure, and the density requirements are much less. Now, over the next year to 18 months, we expect work groups to radically change. Where the work groups are running at, say, shared 16, we see switched 16 to every desktop becoming a realizable technology. When that happens, you're going to need a much high-speed uplink, which will be a high-speed uplink into the core of the network. As that starts to happen, that's when you'll need a much higher density within the core of the network. And you can certainly imagine from Madge next year that we'll be delivering much higher density solutions for high-speed token ring backbones. So you can see that there's really two stages of product. This stage here, first products to market, designed for improving existing token ring backbones. As work groups are upgraded, we do see a need for a higher density, high-speed token ring switch within the backbone.
I think there's something to add to there, that we mustn't overlook the capability of 16 megabit enabled workstations. As I said earlier on, the capability is well beyond the 10 megabit Ethernet standard, and is actually in some cases faster than 100 megabits in terms of raw performance. So, the need to bring in high density solutions has not occurred on Token Ring because it has performed so well over these years.
Thank you very much.